Okay, so now let's look at going the other direction. Let's say I have a number and that number is already in decimal, but I want to know what the binary equivalent might be. We can use our friend, the powers of 2 chart here, to figure out how to do this conversion. So what we want to do is we want to look at this number 45 and we want to say, well, what is the biggest power of 2 that is not bigger than this number? So it's sort of like the Price is Right. You want to get as close as you can without going over. So if I come and look at my chart, I'll see that 2 to the 6th is 64. Well, that's bigger than 45. But 2 to the 5th is 32. So this is the biggest power of 2 that could be a part of this number. So I'm going to say, okay, 2 to the 5th is the biggest power I'm going to have. Then I'm going to need to leave a spot for every other power of 2 all the way to 2 to the 0th. Okay, and we know there's going to be a 32 that's part of this number. So then we say, okay, had 45 and I took care of 32 of it. So then I just subtract and I have 13 left. So I look at the next step, 2 to the 4th. 2 to the 4th is 16, which is actually bigger than 13. So I know there cannot be a 16 that's part of this number. So this position must contribute 0 to the weight of this number. I look at the next one, 8. Well, 8 is less than 13, so I'll say, okay, I'm going to need an 8. I subtract 8 from 13, get 5. I look at the next power of 2, 4. 4 is less than 5, so I'm going to need a 4. I subtract. I have 1 left that I need to account for. The next power of 2 is 2. 2 is bigger than 1, so that means that I'm going to store a 0 here. Right? And then the very last power of 2 is 1. I have 1 left that I need, and I should end up with 0 left to represent. So now I know that if I start with 45 in base 10, the equivalent is 1, 0, 1, 1, 0, 1 in base 2.